So, good day. Once again, we're back to the continuation of the topics from the dynamics of rigid bodies. So, previously, we had the friction, and it's about dry friction, the wedges, and the belt friction. However, it was about friction. This time, let us now go deeper with the dynamics or the topics in the dynamics. Remember that dynamics is the branch of science that deals with motion of bodies under the action of forces, and it is divided into two parts. So, first part would be this one, which is the kinematics, and then the second part would be the kinetics. So, let's go deeper into the topic. So, primarily, this day we will only be talking about the kinematics, rectilinear motion. However, let us also mention the other topics before we go over with the pure rectilinear motion. Say, what is kinetics? So, kinetics is the study of motion of bodies without reference to the causing or to the forces causing the motion. So, basically, uh, we are not going to account the applied forces nganong move ang usa ka body or object. So, what are these examples? For example, a paper airplane, raindrops, dropped an iPad. So, it's basically natural occurrence, or I don't want to mention natural occurrence. However, it's somehow fueled with its nature being or nature that it has a potential energy. So, potential energy meaning there is a probability that it will cause kinetic energy. So, however, we are not going to account the forces or applied forces that causes or that cause the body to move. So, whenever nalata sa portion nga ato nang i-consider ang force nga nung move ang body, then that would be the time that it's already the kinetics. So again, kinetics is the study that relates the action of forces on bodies to their resulting motion. So that is the second part. So we are just going to first study on the kinematics. So again, kinematics is the study of the motion of bodies without reference to the forces causing the motion. Okay, so these are the types of motion that we will be dealing in each part of the 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 branches of dynamics. So first is we have the rectilinear motion, which I had already showed to you that we are going to focus first on the rectilinear motion under kinematics. So rectilinear motion is the motion that is along a straight line with all particles of the body moving on parallel paths at the same time. So, what are the example for rectilinear motion? Like, for example, vehicle moving in a straight path, inclined path, or a free falling body, or an object, or a ball being thrown upward, so or vertically upward. So that's forming a rectilinear motion, linear, rectilinear. So that's the first type of motion. And the second one is the curvilinear motion. This time, the motion is along the curved path. So, like for example, a loop, um, uh, a projectile, and then those are the examples for the curvilinear motion. And then we have also the special case for curvilinear motion, which is the rotation, so in which all particles of the body are traveling along concentric circular paths whose centers lie on the axis of rotation, which is perpendicular to the any circular path. So, what is this rotation all about? Special case of rotation, it's somehow swinging. You have a constant variable, or I mean, not constant, constant radius of swinging or rotating circular body. For example, um, in a basin of full of water, and then you try to spin it around. So therefore, if you consider a certain particle in that whirl of water, then somehow basically it represents curvilinear motion. So it is connected to the fluid mechanics. However, we cannot understand fluid mechanics unless we'd be able to understand what rotation is all about. So in rotation, we will be dealing with centrifugal forces, centripetal forces, the constant radius of rotation, then the angular velocities, and so on and so forth. So that is the rotation. Then let us proceed with the plane motion. This is the fourth type of motion, which is the particles of the body are moving in parallel paths. So it's just the same with the rectilinear motion. It's just that um, we are going to incorporate this one in inclined position, or in sliding down, moving up in an incline. So that's plane motion. Okay, so these are the terminologies that we are going to tackle about, and first one is the displacement. So you know what, or you know already what displacement it is. It is about distance. So this is the change of position of the body relative to a reference point. For example, at time interval 1, the position of the body is this particular point A. Then the at time interval next time, the position of the body is no longer at point A. Hence, it's now at a certain point B. So therefore, the distance from A to B in a curved path or in a straight path is now the displacement. And that is what we're going to account during the kinematics and kinetics. And linear, the displacement is um, could be measured by linear and angular. First is the linear, which is the change in position in a linear distance. And then the angular is the change in position, which is measured in degrees or in radians. So it all depends on how you express the displacement of certain point or a certain body from a reference point. Then that is linear and angular in expressing the methods of measurement. Okay, we have velocity, and you know already what velocity is. Velocity is the rate of displacement, or the displacement per unit time, or that is the distance over time. So such as kilometers per hour, meters per second. Um, it's distance per time. And then we also have acceleration. So acceleration is the rate of change in velocity per unit time, meaning to say the final velocity minus initial velocity over time is a unit change of velocity, or that is the acceleration. Then we have the uniform acceleration, meaning to say there is no changes in the velocities from initial to the final, meaning the movement of the body is constant. So it's the acceleration of the body that is constant for all time intervals, meaning the final velocity is just equal to the initial velocity over time, meaning there is zero acceleration. No? We have also the acceleration due to gravity. So the acceleration of a free falling body and is attributed to the gravitational attraction of the Earth is known as the acceleration due to the gravity, which is the g, or we will always be using the 9.81 kilonewton per, 9.81 meters per square seconds, and that is the gravitational acceleration in SI. Okay, so the conventional signs used for vectors, which is the displacement, velocity, and acceleration, you know already what vectors are. So this in the vectors that involves gravity, we are gonna use the sign convention. For example, upward means to say that the acceleration that we're gonna use, or gravitational acceleration that we're gonna use, is negative. Why it's negative? Because it go against the gravitational pull. Remember that the gravitational pull is always pulling down the bodies. That whenever a body is going up, then it's going to pull down the body. So therefore, it go against the gravity. So therefore, the acceleration must be negative. And then when the body is moving downward, then we're gonna use a gravitational g to be positive, because it goes with the direction with the gravitational pull. So neg downward kung upward, I mean, negative kung upward and then downward positive. So for bodies in motion not involving gravity, the initial direction of the displacement that determines the positive sign of acceleration. So initial niya nga direction sa iyang displacement kay mao sad ang iyahang sign asa kung asa pa dong ang iyahang movement, then always positive ta siya ang atong gamiton nga acceleration. But whenever it go against the motion, then it is now the deceleration or the negative of the acceleration. Okay, so these are the equations for rectilinear motion that we will be using with uniform acceleration. Um, okay, yeah, uniform acceleration. So first is the final velocity is just equal to the initial velocity plus minus acceleration times time. Then the second one is the final velocity squared equal to the initial velocity squared plus minus 2as, or the acceleration times the distance. Then we have the s, or the distance, as equal to the initial velocity times time plus minus 1/2 of the acceleration times time squared. So you have plus minus here because of the acceleration. So when it is moving on a plane motion, then somehow we are going to denote, like for example horizontal, so we're going to denote whether it's acceleration or deceleration. So when it's acceleration, then it's positive. Then when it is deceleration, then that's negative. However, for free falling bodies, then we're gonna use plus minus for the gravity, as the motion is governed by the gravity. So plus again when the motion, when the body is moving down, and then minus when the motion, or when the body is initially moving up. So that's the free falling body nga concept. So here are the elements. We have the final velocity, or VF, the initial velocity, as VI, and then T is the time, and then A is the acceleration, then S is the displacement. So let's proceed with our example.